Okay, so the good news here, guys, is that you did not have to do any continuity stuff on this one. We'll do that together in tutorials if you are seeing me for tutorials. But otherwise, we want to get good at rational functions and non-rational functions and finding the limit as x approaches infinity. Now, I wrote this notation here because if you read the directions at the top of the paper, this is exactly what it's telling you to do for each and every problem. Now, the only thing that scares me about these, and I don't know if you noticed it or not, but the problems given to us, they factor like a lot. In other words, like the number 1, if you take out a negative 2x, you could have an x minus 2 up here. And then on the bottom, if you take out an x, then you would have, what is that, x minus 4? Okay. It's actually important to go ahead and factor these, and the reason for that is because if something cancels, I don't need to write that. If something cancels, then you have to cancel it, and then you need to analyze greater power on top or greater power on bottom or what's happening, okay? So on this one it wasn't as big of a deal because the only thing that cancels on this are these two x's, and it still leaves a power of 1 here and a power of 1 here, and so our answer is negative 2. But on other ones, and you'll see in just a second, it's going to be crazy important. So if you did not do any factoring and canceling, you might want to go back and factor everything and see if people cancel, then come back to this video and see what's up, okay? Otherwise, I'm just going to keep going. Okay, x squared minus x minus 6. So this is going to be like, what would that be? A 6 and a 1? No, a 3 and a 2. Yeah, minus 3 plus 2. Okay, here nothing cancels, so I really can just analyze that this is an x squared on top and that was an x squared on bottom, and there was no coefficients, so that would be a 1. Number 3, when I factor that, I'm getting x times x plus 2, I'm sorry, x minus 2, and on the bottom I'm going to take out a 2x, which is going to leave me with x squared minus, what is that, 4? Now that's going to factor again, actually, guys. So when that factors, it's going to be 2x times x plus 2 times x minus 2, okay? Now lot cancels. This cancels with this, and this cancels with this, and so what we're looking at now is like 1 over 2x plus 4. This is what we're looking at now. So it is on this one still a higher power in the denominator, so the answer is still 0. We're just being careful because if something canceled and it did change our power rules, then we would need to be really, really careful, okay? But the more I think about it, I wonder if something cancels here and it cancels there, then the ratio of the power rules is still the same. So you know what? The only advantage, I'm going to renege on what I said a second ago. The only advantage of doing this factor cancel, this factor cancel, whatever I was doing here, okay, the advantage of that is to find your wholes versus asymptotes. Because if the question was not just find the limit, if it said find the discontinuities, then you would be able to do all of that in one fell swoop. So from the rest of this assignment, though, I think I'm going to quit some of the factoring, we'll see, and just do the problem as is, because this one should be a negative 1/3, even after things factor and cancel. Number 5 should be a negative 1. Number 6 should be a slant asymptote, and this one, since it's a x squared over a negative 4x, when I do that division, I'm getting a negative 1/4 x, which means it's going to slant this way, so the answer is actually going to be negative infinity right there, okay? Number 7, if you were to do that one, it's going to be very similar to the one above. You would factor, you could cancel, but in the end it would still be approaching negative infinity. But if you went through and factored and canceled, guys, that's really good practice, because you do need to do that a lot in calculus, and you do need to understand wholes versus asymptotes, okay? So this next one is going to be 0. Number 9, okay, now we're out of rational functions. So 9, 10, 11, and 12 are a little different, right? This you have to actually think about. And you could think about it graphically, or you could think about it numerically, okay? So I'm thinking graphically. So I've got the graph of sine, which looks like this, but it's -1. So it's going to look something like this. Okay. And I'm trying to figure out what happens back here at infinity, right? When x is infinity. Well, I don't know. I mean, what's going to happen? Is it going to be at the top of a hill? Is it going to be at the bottom of the wave? Is it going to be in the middle of the wave? Since you don't know, because the wave doesn't stop and there is no specific place that it's heading, this limit does not exist. So this doesn't happen a lot. But with your trig functions, you've got to be super careful, because if the values are jumping around and you don't know exactly where it's going to stop, that is going to be your answer. So based on that same logic, number 10 will be the same. Number 11, okay, that's a polynomial, and the leading term is x to the 4th. So I know that on both ends it looks like that. It looks like a parabola that's heading up. And so on the right side, it's heading up. So the answer is positive infinity. Number 12, that one is a cubic. It's an x to the 3rd. And if you know the parent for x to the 3rd, it looks something like that. So on the right side, it is heading up. So that's what I want to go after, is also another positive infinity. So like I said, if you went back and did all this factoring, go ahead and for extra practice, because if you went super fast, you can go through here and tell me, what does this mean? Like, you can write out to the side, since that canceled out, there's a hole at 0, because 0 is where that cancels if it's just an x. So if it's a hole at 0, you could make a note here like removable discontinuity at x equals 0. That would be for extra practice. Here, nothing canceled. So you could make a little thing right here that at x equals 3 and at x equals -2, you're going to have a vertical asymptote, which means a non-removable discontinuity. Did anything cancel here? Oh yeah. So here we have a removable at x equals 0, where that one canceled, x equals 2, and then what was left behind in the denominator? Just that one, right? So non-removable at x equals -2. So feel free to keep doing that on these other ones. I didn't factor those, but you can if you want the extra practice, and we'll definitely talk about more of this kind in tutorials as well.